Okay, let's look at number 9. 1 equals 2 plus p over 4. So this looks a little different than the 2 that we've done so far. But essentially we're doing the same thing. You look for your variable, and then you're going to do PEMDAS backwards in order to isolate your variable or get it all alone. So I'm going to do -2 on both sides first. That becomes a 0. And then I bring down everything that's left, and this is a -1, because -2 plus 1 is -1. Then this p is still not alone, but now the operation that's keeping it from being alone is division. So I'm going to multiply on both sides. So that becomes a 1, because any number over itself is 1. And I clean up everything that's left. So p equals whatever 4 times -1 is, which is -4, because a positive times a negative is a negative, and then probably better math to write it like that. All right, and we just got 10 left to do on this slide. I'm sure there's an easier way to do this that I'll find someday. Oh, maybe it's this. Okay. All right. Let's do 3 minus 6r equals 87. So let's go through our steps. What is our variable? It's r. What's keeping it from being alone? -6 multiplied by -6 and a +3. We're going to do PEMDAS backwards. So I got to get rid of this first. Opposite of +3 is -3. That's a 0. I rewrite everything after I clean it up. I get 84, because 87 minus 3 is 84. Now, my variable is still not alone, so I'm going to divide both sides by -6, and notice the negative stays with it, because it's not like adding and subtracting where you change the sign. So this goes away, and r is going to equal whatever 84 divided by 6 is 14, but it's not a +14, it's a -14, because it's a positive divided by a negative. So r equals -14. All right, let's go to the next slide. All right, so we have v minus 9 over 2 equals -7. All right, this is kind of the exception. You know, we keep talking about doing PEMDAS backwards. Well, when you see one like this, you start with multiplication and division, mostly because you don't want to have to deal with a denominator. And I think everybody can remember that, because nobody wants to deal with the denominator. So here's our variable. First, we're going to get rid of the denominator by multiplying both sides by 2. This becomes a 1, because any number over itself is 1. Now let's rewrite everything that's left. -7 times 2 equals -14. All right, so now we have a one-step equation. I'm going to do +9 on both sides. That becomes a 0, and v will equal whatever's over here, which is -5. Okay, let's try this eraser. All right, let's look at number 12. -1 equals k plus 3 over 9. All right, so again, this is going to be one of those exceptions to the backwards PEMDAS, because we want to get rid of the denominator. So here's our variable. We're going to multiply both sides by 9. This becomes a 1 and goes away. So now I have k plus 3 equals -1 times 9, which is -9. Now it's a one-step equation. I'm going to subtract -3 from both sides. That becomes a 0. K equals -12, because same signs add and keep, but we probably should write it like that. Okay? So now we're on number 13. -7x plus 8x equals 7. All right, so with this one, the first thing we have to do is combine like terms. So this would be a multi-step equation, because we have to do some things before we can start solving it. So -7x and +8x can be combined, because they're both x terms. Same signs add and keep. Nope, different signs subtract. Take the sign of the highest number, then you'll be exact. So that's 1x. And really, this is the end, but if you want to go ahead and finish it this way, that will help if this is negative or if this is negative. So we'll go ahead and finish it that way. All right. Then this one, 2 equals 2 plus 7v plus 4v. All right, so we got to combine some like terms here. We have a 7v and a 4v, 7, 8, 9, 10, 11, so that's 11 v's. Write the rest of it. My variable is v, so I need to get it alone. So the first thing I'm going to do is add and subtract PEMDAS backwards. That goes away. This becomes a 0. If I divide both sides by 11, v will equal 0. All right, let's go to the next slide. All right, number 15. Negative 24 equals 2m minus 6m. All right, so we have some terms we can combine, 2m and negative 6m. That's not same signs add and keep, it's different signs subtract. Take the sign of the highest number, then you'll be exact. And now it's a one-step equation. And again, sorry about any confusion if anybody thought you would leave the negative sign behind, but the negative sign stays with the 4 because we are multiplying or dividing. This becomes a 1, and m is going to equal whatever negative 24 divided by negative 4 is, which is a positive 6. Better to write it like that. Let's see if we can finish this slide before it gets too long. All right, so this one, negative 40 equals 8m plus 2. So first I have to distribute. 8 times m is 8m. 8 times 2 is 16. Now it's a two-step equation. Here's my variable. I need to get it alone, so I'm going to do opposite operations on both sides. This is going to be negative 30 and 8m. I don't remember this one working out that way. Did I mess something up? Oh, I wrote it wrong. Okay, hold on. Let's try that again. All right. Negative 40, so you got to make sure you write things right. Negative 40 equals 8m plus 8 times m plus 2. This is 8m. This is 16. And this is negative 40. 40. Determined to write 14. I'm going to do negative 16 on both sides. This goes away. And 8m will be equal to negative 56. Now that looks a little better. Divide both sides by 8. That goes away. M is equal to negative 7. Because a negative 56 divided by a positive 8 is negative 7.